Everyone, welcome back. So, what do we have here? Well, we're trying to figure out the limits of size. I'm going to apply dimensions for these shown parts. We have a hole on this side and a shaft on this side. Okay. And we're going to do this using the tolerances from the tables in ASME B4.1. Should be in your textbook. If not, you can look it up online. So, I'm going to apply these dimensions using limit dimensions. Limit dimensions is when you have a number on the top and bottom, you don't have the plus or minus, you just give the number. This is the max, this is the min. Now the basic size is going to be a 1.875 inch diameter. Okay, 1.875 inch diameter. So we're going to have a force fit right here. It's going to be class 4. And if we look it up, what we're going to get is our hole tolerances are going to be +1 and 0, and our shaft tolerances are 3.4 and 2.8. 3.4 and 2.8. Now, this is in thousandths of an inch. This is not in inches. That'll be a massive amount of tolerance then. Woo! Okay, now let's work out the numbers here. So for my hole, I have +1 and -0. Okay, +1 -0. So the hole will be 1.875 plus 0.001. And there's not really any need to do any math on the other one because it's just going to be 1.875. And then for my shaft, it's only either going to be plus 0.0034 or 1.875 plus 0.0028. And if I do out the math, what I get is 1.8784 and 1.8778. That should have worked. It did, yes. Did I do enough? I did, good. So these would be my limit dimensions, which I'm going to put in here. Now, let's look at this. The largest hole is 1.876. The smallest shaft is 1.877. This is always going to interfere. The shaft is always going to be slightly bigger, no matter what. And sometimes significantly bigger. And it's going to be forced into the hole by a large force. So how do we apply these dimensions? Well, I'm going to do it just like you would. So I'll do the hole first and I'll draw it to the side. And so we have our hole right here. I'm going to do my line across. I added my center line to mark the center of the hole, the axis. I'm going to do some cross hatches which tell that this is solid and this is a section view. Actually, interestingly enough, the style of crosshatch you use is determined by the material. This is like the basic one, which is just used when you don't care. I'm going to draw an extension line from the surface. It doesn't touch the edge. And I'm going to add my dimension lines, which I'm going to do my best to draw with a very wide pin tip. Okay, let's erase a little bit out of here so I can actually fit the numbers. Now I'm going to put my numbers in. A bigger number goes on top because that's the max. 1.8760 and then 1.8750. Okay, so that's one. I also probably should mark this off. There you go. And now let's do it the same exact thing for the shaft. You don't have to separate yours. I'm just doing it so I can keep it all on the same page and have to move around. So I'll do my shaft right here. Okay, that works good. And then this dotted line is actually saying that this is a hollow shaft, that there is a cylinder in the middle. That shouldn't actually be hollow. This is dots. This should be dashes. Let me make it a little bit nicer. Yes, this is a hollow cylinder. This might be something like a bushing, perhaps. Let's add my center line in to show the axis. And then we'll add in our extension lines, our dimension lines, and then our limit dimensions. Go. Looking pretty good. And so the max would be 1.8784. The min would be 1.8778. Okay, and there we have it. I have these limit dimensions put in place with their extension lines and dimension lines. And these are based off of the class of fit, which is a forced fit right here, FN4. Which would give us these kind of tolerances. Then to figure out what our tolerances should be for our part, We start with the basic size, which is 1.875 inches in diameter, even though neither of these, well, this one can be 1.875 inches, but it's very rarely that. It's just what it's known by. That's its basic roundabout size. And then we add these two numbers to it. If they're negative, we add the negative number, and it will be lower. And that gives us our limits for each. So, I hope this helps you. I hope this makes sense. Thank you for watching, and I'll see you all next time. Bye-bye.